Welcome to The Explainer. Today, we are going to decode the technical interview. We're going to break down the exact kinds of questions that top tech companies love to ask and give you the patterns to solve them with, a ton of confidence. So, you've got that big interview scheduled, right? And that mix of excitement and, let's be honest, pressure is really starting to build. It is a huge opportunity, but those technical rounds can feel like a total black box. What are they going to ask? How can you possibly prepare for everything? Well, let's tackle that feeling head on by getting you ready for the exact problems you are almost guaranteed to face. Look, the secret here isn't about memorizing hundreds of different solutions. It's about understanding the core patterns that just keep showing up again and again, just in different disguises. Once you see the pattern, you can solve any problem they throw at you. Okay, let's dive right into round one. SQL questions. They aren't just about pulling data. No, they're designed to test your logical thinking and, more importantly, your ability to actually see the relationships inside a database. This one is an absolute classic. I mean, at first glance, it seems pretty simple, but it's actually a really clever test of a very specific and powerful SQL concept. What the interviewer really wants to see is if you can handle relationships that exist within a single table. So the key here, the big aha moment, is realizing you're not joining two different tables. You're joining the employee's table back to itself. You basically treat one version of the table as the employee and the second version as the manager, and you link them on the manager ID. Once you make that connection, the rest of the query is just a simple comparison. And here's another one you're almost guaranteed to see. Interviewers use this to check if you can think in layers, right? Can you solve a problem by breaking it down into smaller, bite-sized steps? They're also kind of checking to see if you can handle those tricky edge cases without making your code a total mess. The most elegant solution here uses something called a nested query, or a subquery. Just think of it like a two-step process. First, the inside query runs and finds the absolute highest salary. Let's say it's $100K. Then the outside query takes that result and asks a brand new question. Okay, what's the highest salary that is less than $100K? It's that simple, layered logic that just nails the problem. Okay, this question is a bit of a shift. We're moving from pure logic to your deeper knowledge of how the database actually works under the hood. I mean, both commands get rid of data, sure, but knowing which one to use in which situation, that shows a much deeper understanding of things like performance, resource usage, and data integrity. So let's break down what this actually means in the real world. If you need to remove just a few specific rows, delete is your only choice because it supports a where clause. But if you need to wipe an entire table clean, truncate is dramatically faster. Why? Because it does way less logging. It's that classic trade-off, speed versus precision. Now here's a pro-level follow-up they might hit you with. How would you optimize a query that needs to filter by year? See, when you apply a function like year directly to a column in your where clause, the database often can't use its index on that column. It's forced to do a slow, full table scan. But if you rewrite it as a direct date range comparison, you let the database engine use its index and find the data, exponentially faster. All right, let's shift gears. Time for round two, algorithms. While SQL tests your data logic, this is where they really test how you approach abstract problems and, how you write efficient, scalable code. This problem, often called valid parentheses, is all about order and making sure things match up. They really want to see if you can pick the right tool for a problem that requires handling things in a very specific, kind of reversed sequence. This is a classic last in, first out type of scenario. And the perfect data structure for this job is a stack. Just think of a stack of plates, right? The last one you put on top is the first one you take off. We're going to use that same LIFO principle to keep track of all the open brackets we find as we go through the string. So here's how the logic works. We scan the string one character at a time. Every time we see an opening bracket, like an open parenthesis or a square bracket, we just push it onto our stack. But the second we see a closing bracket, we pause. We peek at the top of the stack. Is it the matching opener? If it is, great. We pop it off and just keep going. But if it's not a match, or if the stack is totally empty, we can stop right there. The string is invalid. And if we get all the way to the end, there's just one final check. The stack has to be empty for the string to be truly valid. What this gives you is a really efficient approach. We only have to look at each character once, which gives us a runtime of O of n, or linear time.
All that really means is if the string gets twice as long, our solution will take about twice as long to run. It's a clean, fast, and scalable solution.
Ah, the two-sum problem. This might be one of the most famous interview questions of all time. It's a fantastic test of whether you can think beyond just brute force and use the right data structure to really optimize for speed. Now, the brute force way would be to check every single possible pair of numbers, but that is way too slow. The key to a fast solution is a hash map. Its superpower is near instant lookups. So instead of searching for a number, you can just ask the map, hey, have I seen this number before? In basically no time at all. This logic is just so incredibly clever. You iterate through the array only one time. For each number, let's call it x, you figure out the difference you need to reach your target. Then you just ask the hash map, hey, have you already seen this difference? If the map says yes, you've found your pair, and you are done. If not, you add x to the map so you can find it later, and you just move on to the next number. By using hash map, we get another beautiful O of n, or linear time solution. We've basically traded a little bit of memory to store the map, but in return, we've massively improved our speed from O of n squared. That n squared solution gets exponentially slower as the input gets bigger, but ours stays fast. Making a smart space for time trade-off like this is exactly what interviewers want to see. Okay, so we've looked at the questions, we've seen the patterns. Let's zoom out. What's the high-level strategy that connects all of these solutions? The thing that's going to make you really stand out in that interview.
So what's the real takeaway here? Well, getting the right answer is only half the battle. You have to understand the fundamentals, you have to recognize the patterns underneath, and maybe most importantly, you have to clearly explain why you chose your solution and what trade-offs you made to get there. Thanks for watching The Explainer. The key now is to turn this knowledge into action. So as you practice, don't just ask yourself, can I solve this? Instead ask, what is this problem really a test of? Because the moment you see the pattern, you don't just solve the problem, you own it.